Hello, so we are going to discuss Unit 2, launching a STEM project. I'm going to start with the slideshow, so that is what you should also start with always. Slide number 2 is going to have your podcast and the instructional video, which I am creating right now. So when I'm finished with that, it will be right here. You can launch the podcast, listen to it as you're reading, or you can listen to it alone, or you can listen to it as a review, whatever you need to do to help yourself out. With this unit, you're going to learn how to apply a design cycle to a STEM project that has a problem to solve. You're going to prepare for a STEM project by asking questions, seeking answers through research. You're going to research sources to find STEM tools and identify which ones will support a project. You are going to determine when the design cycle is complete and a project is ready to launch. All right, Unit 1, Chapter 1 is a better design. With this, you're going to learn quite a bit about STEM, what makes it unique, and what ways you might use it in your future career. First, warning: the untrained eye, STEM often seems like making more work. To be honest, it's kind of true. If you were assigned to build a bridge out of some pieces of wood, which of these two situations would be easier? Identify the requirements of the project, do some research, the elements of a good bridge, calculate the best size and angles, um, potential designs, select the best design, build a digital model, run some simulated tests, tweak the model as necessary, finally build the bridge. Or grab some sticks, glue, and put them together, right? The STEM model seems like a lot of work, but, it is doing it right the first time or doing it multiple times, right? So some of you are doing it multiple times when you take the test before you do the activities. You're jumping ahead before you know all the information. So it's important to know the information before you just jump into it. All right. So understanding a systematic approach may take more time, but it's going to give you better results. All right, so keep this in mind when you're moving through this unit. STEM is not just about making things easier, it's about making them better and more efficient. All right, so that's kind of what we're doing in the real world as well. When we're fixing those smartphone glitches, when we're fixing these bridges or making medical breakthroughs, we're not just, fixing dumb things. We're making things better for the environment, for the world. So the design process is the process that the engineers use, much like what I just discussed with the bridge. It's iterative, which means it kind of flows with what needs to be done. It's repetitive. Sometimes you miss a step. Sometimes you have to go back a couple of steps, depending on where you are in the process. So you have to do what you need to do to get the job done, but you have to do it proficiently. Okay. So the stages or the steps of the design process are important to understand. And you're looking at a 4-stage design process: ask and research, imagine, create, and evaluate. So the design process has a lot of steps. There's up to 8 steps, but you can simplify that as long as you get them all in. So step 1 is act and research. So the first step of any design is you have to figure out what it is that you're acting on, what is your problem. Okay? Involves looking at the issue, asking yourself about the problem, the criteria, the constraints. The criteria, as we know, is which what do you want to be involved in your solution? What has to be in your solution? Constraints are your limitations, like the size of your product, the money that you have allotted, the time, your target audience, the laws involved. So time constraints are your limitations. Criteria are your the things you must include. Okay. Um, mm-mm. And then your research, you have to figure out what it is that these things need to include. All right. So you're researching, you're asking the question, and you're researching the answer. The next step is in the imagine. Your invention, your innovation, you're figuring out, um, you're visualizing, you're drawing, you're sketching, you're brainstorming. What are some of the potential solutions to this problem that meet these criteria and constraints? What are your plethora of solutions? Okay. Lots and lots of solutions. Open forum, a place where the whole group, you can ask the whole group, what are some possible solutions? Nobody's wrong. Okay. Then after you've come up with your brainstorming, lots of different solutions, then you have to narrow it down to your best option. So based on your criteria and constraint, everything must be based on your criteria and constraints. Then you have to narrow it down to your best solution, okay, to come up with. That's the one you're going to create a prototype for. All right, so you're going to build a prototype based on your criteria and constraints using cheap materials like cardboard, paper, anything that you can find that's recycled. All right, you don't want to use anything that's going to cost you a lot of money because it might not work. Okay. Once you have it created, then you're going to evaluate it. You're going to look at the criteria and you're going to say, did that work? Does that meet that criteria? Does that meet that constraint? Okay. And if it doesn't, then it didn't work. And then you have to go back and you have to improve it so that it does. Okay. And iterate to improve. You can watch this video to help you understand that. There should be a link to this video. Probably won't work in slideshow view. You have to put it in slideshow view to watch it. And then evaluate. You're still evaluating. How do you know when you're done? When you take a look at the final lesson and unit, so the 4 stage, you know when you're done when you've answered all of the questions and you have made any changes and everything, all the criteria and constraints work, okay, after you've evaluated that. And then chapter 2 talks about building your background. So, reasons and ways to do research for STEM projects. So STEM is about exploring new and creative ideas. So you'll generally be learning things in order to create something as opposed to presenting the ideas. The facts you learn will serve a specific purpose. So your background knowledge, so what you already know is going to kind of help you. Sometimes research is used to fill in the gaps or grow what you already know. So it's important to do background knowledge to kind of help you add to your information that you already know. Okay, having a puppy or a kitten is great, but does it help you understand how to raise a baby goat? Probably not. Okay. So constraints, remember, we think that that's obvious, but do you know, did you try to build something and you grabbed some cardboard and a bed sheet and think that you were going to do something? Well, you have to know about all of the constraints like budgets and different sizes of material. You need this sort of thing to work. Design elements. Research can help you identify some important design elements of what you're building. If you're designing a house, research what you need elements to make up a house. Different types of rooms, roof shapes, heights. height of steps, size of doors. Okay, so those are design elements. Generating new ideas. Researching a problem can take you on an adventure. You read one thing and it sparks an interest in something new. Okay. Finding good information and sources talks about credibility, accuracy, and relevancy. All right, so think about how trustworthy or believable something is, how true or correct something is, how well connected or appropriate it is. Okay, so here's more information on these. I think these are quiz questions. So make sure you keep these in mind or you refer back to them when you take the quiz. Content sources. STEM is all about science, technology, engineering, and math, so it makes sense. The textbooks, short lessons on YouTube, or other internet lessons are a great place to start. All right. And then research papers are usually a pretty good collab for STEM papers. Google Scholar is a place to go for help on STEM projects. And then experts. Okay. Chapter 3, picking the right resources. All right, so we're talking about here what resources in certain STEM fields. Tools, money, and people. Tools and technology. 3D printers. I have one in my classroom. Smartphones, smart TVs, smart cars. Laser cutters. Budgeting. Okay, so I have to budget. I have a budget for my classroom. I'm able to purchase some things. Thinking about getting another additional 3D printer if I can. Finding the experts in the STEM world. Trying to figure out, would you guys be interested in having someone come in? What kinds of things do I need to get to make you interested in STEM? Chapter 4, making decision. You may have noticed the design cycle is a circle. It keeps looping around and around. You may have made you wonder, where does it end? It really doesn't. It's iterative. Okay. There are lots of STEM professionals, and they are usually detail oriented. They have some time pressures to keep their jobs going. They have deadlines. They have to meet objectives. Um, Failure is usually not an option for some people in STEM jobs. Here's about a sticky notes were created by accident. So this is an example of how adhesive on the back of a sticky note isn't very strong, but that's what makes it perfect. And then a new purple, better farming. Okay, so creatively trying to solve problems with new ideas, never ending loop. Here is a first set of headphones, the drawing for it. And then here's an in-ear, the drawing for the first in-ear headphone. And then you have brand headphones, and then musical headphones, how they've come along. And then you have the new tech headphones. And okay, so now we have our knowledge check. And our activities. So with our activities, we have our knowledge check is here. Our critical thinking questions. You learn that headphones are an invention that slowly and methodically evolved over time using a gradual process of tests and refinements. Identify another invention or innovation that has evolved in the same way over time. So basically, this is a you question. You can pick anything from the phone to the television to a hairbrush, anything that has evolved. You can show me pictures. You can explain how it's evolved just the same way that we just looked at this. All right. How has it, headphones designed, evolved over time? Okay, so they slowly worked over time. What has it done? In 58, give me dates. All right, so first headphone, 1890s, and then 1891, this happened. And then in 1920, it was improved, and then 1958. Okay, so just give me a rundown of what happened and what your invention or innovation was. The team of researchers at your company wants to start turning their digital models into 3D models. The researchers want to be able to create them out of plastic or resin. The models need to be detailed, but they do not have to have a lot of money to buy software or devices. Identify which resources would best fit their needs and why. Think of at least 2 resources. What would you use? Would you use a 3D printer? Would you use a laser cutter? Okay, here's some different options. 3D printers would be one option, right? You can use plastic or resin, right? What else would you use? Could you use, um, you know, cardboard? Could you use cardboard with that? I don't know. What does it ask? It's telling you it needs to be made of plastic or resin. So you can think of 2 resources. So what type of resources? You can use 2 different types of printers, 2 different types of resin. Resin costs different kinds of money. Plastic, right? So what 2 type brands of 3D printers could you use? All right, think about that. While you may have work on your own from time to time, many big projects are completed with other people. Describe the best ways to work with others. Begin by defining brainstorming and explaining why it's good to come up with ideas. Then, describe how you can have good relationships with others in the group, even if they're different from you. So, brainstorming is coming together with a large group, throwing out ideas. Nobody's ideas, no, there's no bad ideas. Okay, everybody's idea should be valid, and you should write down everybody's idea because you have no idea what's going to work and what's not going to work. Once everybody's idea is written down, then you come up with, okay, here are the criteria, here are the constraints. Then you identify which ideas are going to match those criteria constraints using what's called a decision matrix. Okay, so a decision matrix, you write all their ideas down and then you put your requirements in there, and then you go about that way. So you have to have, a plan in place to figure that out. So everybody's idea is a valid idea. The STEM design process is utilized in all STEM related fields. This process is generally iterative, which means it kind of circles around. Okay. Identify the steps in the STEM design process and explain why this process is considered iterative. Again, going back to the slideshow, going to here's your design process here. Here's your design process. Here's iterative, which means it's steps build on the last and repeats as many times as necessary. All right, so this talks about each of the steps right here. Okay, so you're going to go to chapter 1, and that's going to give you the information you need. All right, slide 8 tells you about iterative, and then slide 10 talks about each of the steps, starts with the steps. So that'll help you answer number 4. And then number 5, innovation and invention are 2 terms that are often used interchangeably, but they actually mean 2 different things. To find both innovation and invention, then explain how they're different. Again, I believe that was mentioned in the slideshow right here. On slide 12, invention, it means imagining a new design, new device or system. And innovation means a modified product or system to better solve your problem. So invention is something brand new. An innovation is a modified product or system. So it's something that's already exists, but is modified. Okay, and that is your critical thinking questions. Next assignment is activity 1. Is there a perfect design? So with this one, what I'd like you to do is think about a product. In just any product, you're going to choose a topic in order to explore the design process. So I want you, for like the Toy Rockets product that was in the slideshow, was an example. So if you don't know what I'm talking about, you can go to the Toy Rockets section in the slideshow. It's in there somewhere. Okay, sorry. Okay, so what you're going to do is you're going to jump into the role of problem solver. You're going to explore a topic of your choosing to determine if there's such a thing as a perfect design. So first thing you're going to do is choose a topic and explore its design process. So a topic is an area with many similar designs or products. For example, toy rocket is a good topic because there are lots of different designs for toy rockets, but they all basically do the same thing. For this activity, you're going to choose something simple that is easy to research. For example, cars wouldn't be a good one, okay, because there's too many different cars. So what I want you to do is just think about any topic, and here's some choices here: fences, hairbrush, forks, kitchen timers, fans, rocket ships, whatever. So pick one. It can be anything: tennis shoes, coats, hats, whatever. So once you pick your topic, then you're going to go online and you're going to find 3 different versions of the same item. Okay. So 3 different versions of a hairbrush, for example. Then once you find that, you're going to find 3 different versions of that design item. Then you're going to find actual designs. So try to find like design pictures, like design sketches on how they were going to build it. Okay. And then find 3 or more resources to help you understand the design process. So how were they going to build it, right? Think about the design process that's in the slideshow. How did they research? What questions did they ask? What were their sketches? Things like that. How did they improve it? Things like that. Okay. And then kind of add that to your slideshow, so to speak. If you do a slideshow, that would probably be the easiest way. So add those types of things to a slideshow. And then while you're exploring, try to find their criteria and their constraints, and try to find their background information and their data that helps kind of compare the different design ideas. Okay. So say for example, I'll do hairbrush designs. See what we come up with. Why did it give me airbrush? Did I spell? Yep. Hairbrush designs. Okay, so design your own hairbrush. See, lots of different hairbrushes. designs. So the art of designing a hairbrush. So maybe something, this gives me some information on the art of designing a hairbrush, bristle patterns, volume, tuft profile. Okay, so that might give me some information that I need. So think about, what you're looking at and how that helps you. Okay. So that's what I'm looking for with this idea. And so what you're submitting is you're going to submit a slideshow, um, a audio recording, a digital map. Slideshow would probably be the easiest way, but you're going to submit your chosen topic and then your criteria, your constraints, your background knowledge, your data, and then the thoughts on there's no perfect design. So what did you come up with? Is there or isn't there? And then you can show me like your pictures of your different design ideas and then the pictures of what you found with your different ideas and constraints from your different design ideas. Okay, so you're gonna kind of show me what you found, and then really the most important is like, what are your thoughts on this? Okay, what are your thoughts? Is there a perfect design, and how did you learn if there was or wasn't? All right, so that's this one. And then your Tinkercad house, I will do a separate Tinkercad video for this one. But essentially, you are creating a Tinkercad tiny home for in Tinkercad. So similar to what you did in Tinkercad before. So you're going to create a home that fits within a 15 by 20 foot area. Um, it needs to be, so you need to change the area so that it was like a deserty area. So think about the roofing and the siding and the windows. What other constraints do you think you'd want to include if you know that it's going to be a hot area? Think about your materials, your design elements. Um, Maybe you want to put a pool in the backyard since it's hot outside all the time. Maybe it's too hot to have a pool. I don't know. If I lived in the heat, I'd want a pool. I don't know. Um, you could do a sketch first before you draw it out in Tinkercad. You don't necessarily have to have an inside of your house, but you can if you want. That would be over and above, so that would help you out with a 4. So what to submit is a list of your criteria and constraints for your house, a sketch before you drew it, so your drawing of your house and your layout, and then your Tinkercad, and then an evaluation of your design. Did it meet your criteria and constraints? And then a note about what you would modify with your house. So this, along with your picture design, your SketchUp design screenshot, should go here. All right. And again, I'll do a separate video for Tinkercad. And then finally, your quiz. And I would ask you to You are welcome to use the slideshow when you are doing the quiz. It's not, it's an open notes, always open notes quiz. I never have a problem with that. So use your quiz, use your slideshow, use your activities to help you be successful with the quiz. All right. Hopefully this helps, and I hope you guys can get to work. All right. Because I'd like you to have some of this done before I return.